Welcome to the second lecture on Entity Relationship Model for PGDCA second semester students, paper 107, DBMS Unit 2 for ER model. In this video, we will cover the following details like keys, generalization, specialization, aggregation, steps to design an ER schema, and reduction of ER schema to tables. First of all, let's understand what a key is. Keys play an important role in the relational database. It is used to uniquely identify any record or row of data from the table. It is also used to establish an identity relationship between tables. For example, in the student table, SID can be uniquely defined because name can be same for a student, for many students. Courses can also be same for many students. Therefore, SID is an unique identification for each student. Similarly, in EMP table also, an employee has a unique identity that is known as EID, because again the name and department can be same for many people. So keys are used to uniquely identify any record. There are various types of keys like the primary key, candidate key, super key, and the foreign key. Let's discuss each of them. The first one is known as the primary key. This is actually the first key which is used to identify one and only. It is the first key which is used to identify an entity uniquely. The key which is most suitable for those lists becomes a primary key. In an employee table, EMP ID can be primary key since it is unique for each employee. Candidate key is an attribute or set of attributes which can uniquely identify a tuple. The remaining attributes except for primary key are considered as a candidate key. Let's understand candidate key with an example. In the employee table, EMP ID is the primary key, but there are many other attributes for an EMP like SSN, passport number, license number, etc. They can be considered as a candidate key. They have also some unique properties like EMP ID, but EMP ID is the primary key, so rest of these attributes can be taken as a candidate key. As the name suggests, candidate, they can be used as a primary key at some instances later. The next one is known as the super key. Super key is a set of attributes which can uniquely identify a tuple again. Super key is a superset of a candidate key. Let's see with an example. Here we have an employee table with employee ID and employee number. The name of two employees can be same, but their employee ID can't be same. Hence, this combination can also be a key. We can combine together these two attributes together to form a new key. Hence, this combination can also be a key. The super key would be EMP ID or EMP ID, EMP name, etc. Another is known as the foreign key. Foreign key are columns of the table which is used to point to the primary key of another table. In a company, every employees work in a specific department, and employees and department are two different entities. So we can't store the information of the department in the employee table. That's why we link these two tables through a primary key of one table. But we add the primary key of the department table, department ID, as a new attribute in the employee table. Now, in the employee table, department ID is a foreign key, and in the department table, department ID is a primary key. So DID will be a foreign key in employee table. Coming to generalization. Generalization is a bottom-up approach in which two or more entities of lower level combine to form a higher level entity if they have some attributes in common. In generalization, an entity of a higher level can also combine with the entity of the lower level to form a further higher entity. Generalization is more like subclass and superclass, but the only difference is the approach. Generalization uses the bottom-up approach. Here we can see with an example. We can see that we have an entity called person, but we can generalize employee and visitor to create a higher level entity called person. And this is known as generalization. Now coming to specialization. It is a top-down approach in which one higher level entity can be broken down into two lower level entities, just the opposite of generalization. Let me explain this with an example. Here, in an employee management system, employee entity can be specialized as accounts and programs based on what roles they play in the company. So this is breaking an employee into two different parts. Aggregation. Here, relation between two entities is treated as a single entity. For example, college entity offers course entity. This is a single entity. But there is another relationship. College offers admission to hostel. Here we see that if a student joins a course, he joins the hostel too. So this can be treated as a single entity. So no need of differentiating it into two parts. Now we will learn about the steps to create an ER schema. Here we see, first of all, we have to identify the entity types. For any given system, there may be many different entities, All those have to be identified. Second, we must identify the relationship between these entities. Now identify and associate attributes. Each entity has attributes. All those attributes which are required for our system has to be identified, and one must find the relation between entities, relationships. Now we have to determine the attribute domains also. Another important thing is the primary key attribute for an entity type. Each entity can have a particular unique primary key that has to be determined. Then we can associate cardinality ratio with relationship types like one-to-one, one-to-many, or whatever we have learned in the earlier lecture. There are many types of relationships, out of which relationship is the best for a given relationship is to be defined. Then the generalization, specialization, hierarchies are to be defined to design our schema. After the ER diagram is created, we have to reduce the ER diagram into a table. And how to do this? This can be done with the following way. The database can be reduced to a collection of tables. In the database, every entity set or relationship set can be represented in a tabular form. Like, I'm just taking one entity, student. Student has so many attributes which were defined. It can have a primary key. It can have many attributes. All that can be converted into a schema called student, role, name, marks, admission, etc. So these are converted into a table. An entity can be converted into a table. All the entities similarly can be converted into different tables, and a relationship between the entities can be created in a DBMS. Thank you.